Weekend. Thank you for being here on President's Day. Is that what today is? It's a holiday, right? Not for us, I guess. All right, so the exam, which took place on Wednesday of last week, I have those graded. I've posted your grades in Canvas. If you haven't looked at that, just go ahead and log into Canvas and click on our class, go to grades. I would give them back to you today, but I still have 3 students that had excused absences that day. So they have to still take the test, so I'm not going to pass out the test until those students are done, all right? Overall, the grades were not too bad. The class average on the test was a 76, and then you have what's called the standard deviation, which is a number that shows like how far apart people are from one another. And the standard deviation in this class was 14.8. All that means is that that's about average. That's what you see in most classes, about 14 points or so. So nothing sticks out as being crazy. We had 5 A's, 6 B's, 2 C's, 3 D's, and 4 F's. So remember, a C is higher than a 70, a D is between 60 and 70, and then an F is anything below 60. So here are the actual students in the class, the grades, highest to lowest, and then the orange line is passing. So everyone from basically about here over passed, and then these are the students that didn't pass. There it is. I'm just showing you so you know where you are, okay? Any questions on the exam? I mean, I know haven't passed it back, but are there any issues or concerns?
Oh, I didn't turn in my review.
You have it?
Yes.
Yeah, you can turn that in.
Okay.
Yep. Yeah, so these grades do not have the review, which I said was worth, what, 5 points?
Yes.
So these grades do not reflect that. So if you turn in the review, or if you have it today and you want to turn it in, I'll add the 5 points. All right? Any other questions? Yes?
Okay, so I just want to say, this, the class average, because this is my second time taking this class.
Uh-huh.
So, last semester on our first test, he said our class average was 42.
Was it 42?
Yeah.
Oh, okay.
So, I mean, it's pretty, good
Compared, yeah. Well, you have to keep a couple of things in mind, and this is what I was going to say, is that, remember, I gave you a review with the answers. We went over the review, part of it. Then everyone had the chance to take the test, the no-risk test, right? And then came in 2 days later and took the real test, which was basically a copy of the practice test. So my guess is that had I just given you the test on Wednesday and not given you that Monday test, that these grades would be significantly lower. Now, moving forward, I don't mind continuing to do a no-risk exam. However, we have to make sure it fits into our time, and I might raise the bar a little bit, or I don't know. I need to figure out how I want to do it. Let me just, I don't want you to expect it, okay, that you get 2 chances at each test. I'll do something, but I need to think a little bit more about it, how I want to go ahead. But for this first test, I just wanted everyone to kind of see what I was going to ask, how the test would be formatted. All right, so let's see how things go from here on. I mean, today there's good news. There's really good news, and that is you are now allowed to use your calculators. All right, not your phones. You cannot use your phones. All right, so today I'll make the exception that you can use your phone only today, but from here on out, if you don't have a calculator, then you just don't get to do the work, okay? So does everyone have a calculator that they can use?
Yes.
Available to you? Make sure you get just a basic 4-function calculator. That means addition, subtraction, multiplication, division. You don't need to go spend $50 on a calculator. If you don't have one, go to Walmart. I'm sure you can find one for like $5-6. All right? But make sure you have one. No phones allowed. All right? Questions on that? Yeah, so it was I think decent.
I did a lot better.
Yeah, on the second one? Yeah. Well, the way that I think you need to proceed is when I give you that exam review, you know when I give you the review, you should go home and sit down and try and do that review as if it were a test. And, you know, like try not to use your notes. See how much you can do. Treat it like a testing environment at home. And then when you come in to take the test, I think you'll be a little more prepared. Okay, nothing else to say about the test. Students did ask me to start recording classes again, so I will do that. Hopefully I'll not say anything I regret on camera. All right, so today is a holiday, right? We already said that. So I'm going to try and get us in and out of here, all right, as quick as possible. However, I need you to make sure you understand the material. The good thing is I think this material is stuff that you've all seen and that you're comfortable with. And the fact that we can use our calculators is going to make this even easier. All right? So we have 3 sections to cover today. It sounds like a lot, but I think we're going to knock them out really quick. I just ask you to please let me know if you're confused on something. So we are doing chapter 1, section 4, so we're kind of jumping around. We're going to talk about rounding. And the first thing we're going to do is talk about rounding whole numbers. So when we talk about rounding, first of all, we need to talk about numbers, okay? And when you have a number listed, I'm going to try and write a number in here. I know this looks confusing, but I'm going to put a decimal point right here. And I'm going to put some numbers in front here. 3, 4, 7, and then 2, and then 5. Okay, so the number 734.25, right? So what do each of these digits represent? So hopefully this looks familiar to you. The first number to the left of the decimal point is how many ones we have. The second number is how many tens. The third number is how many hundreds. And then this is kind of like up to you. Like what do you know? Like how far can you go? So ones, tens, hundreds. The next place is thousands. I think everyone's probably comfortable with that, right? Then 10,000s, then 100,000s, then millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. And then it goes on. Anyone know what goes after billions? Trillion, 10 trillion, 100 trillion. Gazillion? I don't know. Yeah, there's names for them, but we'll just stop there, okay? We're going to stop at billions, all right? Now, the other way, this is the part that I think confuses most students, is going this way, to the right of the decimal point. You start out, this first digit is how many tenths you have. So the way I like to look at this is, like, your first digit to the left of the decimal is how many ones you have, right? So think of that as like one candy bar. We've done this before. This next digit right here, this 2, is how many tenths you have. So it's like if I take that candy bar and I cut it into 10 pieces, 10 equal pieces, then that 2 would mean I have 2 tenths. Okay, so that's what that digit represents. So it's kind of like a fraction, isn't it? Even though it's written as we call this a decimal. A decimal is a fraction, and a fraction is a decimal, and we're gonna actually do that later today. So this is how many tenths you have. This is how many what? Hundredths. So tens, tenths are not the same thing, right? Tens is like, 1, 2, 3, 4. You count tens. This is tenths, and that's a fraction. The next digit is how many hundredths. So that would mean 5 hundredths means if I take that candy bar and cut it into how many pieces? 100 pieces. So there's 100 little pieces in here, right? And you're taking how many of them? 5. So 1, 2, 3, 4, 5. You take like part of it, right? 5 100ths. Then the next thing is thousandths, 10 thousandths, 100 thousandths, millionths, and then we'll stop there, okay? So, Yeah, do you want me to draw the one of the millions and I'll just do a million little pieces? Yeah, we'll be here all day. Don't we want to get out of here? Okay, so this first little example, I read through this earlier and I was like, this is just kind of overcomplicating things, but let's go through it anyway, all right? So when we see that number, 85,000, comma, 274. All right, 85,274. Right. So when we look at this, this right here, this 8 is telling us how many what's that we have?
10,000.
10,000ths, right? So this is the ones position, tens, hundreds, thousands, 10,000ths. So I'm filling this out here. This says we have 8, I'm using words, right? 8 10,000ths, and that's 80,000, right? 8 10,000ths would be 80,000. How about this next one? The 5 here is how many thousands we have, right? So I fill this out, I'd write what? 5 thousands. I'll just say thousands. Now I know you don't have this in your notes. Like, I mean, you don't have this to write off. So if you're writing this down, just write the whole thing. 5 thousandths equals 5,000. All right, 200ths. 200ths, that's the 2, right? What does that equal to? So what am I going to write over here? Like the actual number, 200, right? So you see on the left side is the words, the right side is the number. So I have 200ths, that's the 200. The 7, right? 7 here represents how many whats? Tens. So we have 7 tens, and that would be 70. And then the 4 is how many ones we have, right? So we have what here? What goes here? 4. Bless you. 4 ones. So when you put this all together, you have 80,000 plus 5,000 plus 200 plus 70 plus 4. So we have 80,000 plus 5,000 plus 200 plus 70 plus 4. And when we put that all together, what do we get? 85,274. So do we agree that this number, the way it's written, when we write numbers, right? It's just a condensed way of writing something a little more complicated, right? Yes. Each digit represents something here, right? Okay, let's move on. So let's write the following numbers in words. All right, that first number. Who wants to volunteer how I would write that first number in words? It's like you're writing a check, right? If you've ever, does anyone write checks? I get pissed off when I'm in line at HEB and someone breaks out the checkbook. Am I the only one who gets pissed off at that? I'm like, are you serious? You're gonna write a check right now? Yeah.
So like I had to, one of the employees had to call me, and I was like, someone write a check, and I was like, I can't make a check right now. I had to wait until after.
What were they writing a check for? For their membership?
No, it was like to buy some chips, good chips.
Chips?
And they're like $5.
That's when you just hand them the bag and you're just like, get out of here.
I was like, they could just take the bag.
Yeah.
In front of the car. Can they wait? Like, no, they're mad. I'm like,
Checks are kind of obsolete at this. But let's just see if we can write these numbers in words, all right? So who wants to volunteer how you do that first one? You want to go for it? How would you write that? Oh, well,
I mean, I can
here,
see it.
I'll write it here for you. 6291.
Oh, 26,000.
6,000?
Well, 6.
6,000.
It's literally 6 to. I can't. I know how to write it, but I can't say that.
Okay. You want to pick up?
6,291.
200. And then what? 91. All right. What do y'all think? Anybody disagree?
I don't
You sure?
disagree with
Mm-hmm.
Does the comma mean and?
The cousin, what? The comma doesn't have anything, well, I mean, it helps us keep track. The comma is only to separate groups of three. So you know when you're like moving from ones, tens, hundreds over to thousands, 10,000, 100,000, over to million, you know? Other than that, the comma is not going to play any role in the wording. Does anyone have another suggestion, or are we happy with this?
Wait, a period does go right. Like if it's one that has a period.
That's a decimal.
That's
A decimal? We don't need to put the decimal here, no.
But one that does have it.
If it does have a decimal, we would have more words. You're saying like if this was like 0.2,
Yeah.
then we would have more words. Yep, and 2/10. Okay, so the decimal will play a role. Okay, so here's a mistake. This is correct, but here's a mistake. You'll hear people say it, and it's incorrect. 6,291. 6,291. That's the way some people say this. 6,291. It's not correct. Okay, you just 6,291. No and in there. All right. How about the next one? Who wants to volunteer for the next one? Go ahead. What do you got?
406,907.
Okay, so hold on. 400.
And 6,000.
No and.
Okay, yeah, 406,000.
406,900. 17. See, no ands. No ands. 460,917.
You said 60.
What did I say?
You said 60.
Oh, I did?
Yeah, 60.
Okay, 406,917. Sorry, said it wrong. All right, so now let's talk about rounding. When we round things, we have a set of rules. Let's see if these rules ring a bell. When we want to round a whole number, we underline the number in the place value you want to round to. So if someone wants you to round, they have to tell you what place value they want you to round to. So they may say, round this to the nearest hundred, or to the nearest 1,000, or the nearest million. They have to give you that. So we're going to underline that place value first. Then we look to the right of that number, to the number right to the right of it. If the number we see is 5 or higher, we're going to round the digit that we underlined up. If the number to the right is 4 or less, we're going to leave it alone and put zeros after it. Does this sound familiar to you all? Rounding is something you've done? Okay. Let's do some examples, and then hopefully it'll all kind of come back if you've forgotten. So look at this first one. Round 4,692 to the hundreds place. Hundreds. So I'm going to rewrite this. All right, first thing I do is underline the place value of what I'm rounding, which would be which digit? The 6, right? So we are going to underline 6. And now I'm going to look to the right of this. Noah? You there? Yeah. Okay. So I'm going to look to the right of this, and that number there is higher than 5, which means I'm going to do what? Take that number and increase it by 1. So I'm going to take this and go 4, comma, that goes to 7, and then what goes after the 7? Zeros in the place of the other two numbers. So 0, 0. So 4,692 rounded to the nearest hundreds is 4,700. Pardon? Because we're basically saying, is this number close? Like, what is the nearest hundred that this is close to, right? So if we put 702, then that's not the nearest hundred. Now you're looking at the ones position, right? I like to think of it like on a number line. Let's say this is 4,600, and this is 4,700. Then 4,692 is like really close over here, right? Close to this. So we're saying, like, what is it closer to, this or this? And it's closer to this one, right? We wouldn't want to say 4,702. We're looking at what is the nearest 100 that it's close to. That make sense? Okay. All right, the next one. Who's going to volunteer to read the number to me first? If you've already volunteered, you have to wait. So go ahead. What do you got? How do you say this number?
25,437,520.
520. See, we all do it. We all do it. It's hard. That and, like, it's just a natural thing, but technically it shouldn't be there. All right? Okay, so good. Now we want to round to the nearest millions place. So somebody else tell me what digit to underline. We've already gone here. Let's go to this table over here. Whoever. All right, what do you want? What digit am I underlining?
5.
The 5. Which one?
The 1.
Yeah, right here. Okay. And then you're going to do what?
Go to the right.
Look to the right, and what do you see? 4. And what does that mean I'm going to do?
It doesn't matter. Oh, it goes to 400, right?
So if this is below 5, which it is, right? Then we are going to leave this number alone and put zeros all here.
Yeah.
Okay? So 2, 5, comma, 0, 0, 0, comma, 0, 0, 0. Okay, so this 4, we don't do anything to it. This is just to tell us, this number is just to tell us what we do with that number. And then once we figure out what that is, everything is 0 past that. Okay? So what is this number? Let me read it to me.
Okay, 25
Million, right? 25 million. And look, we wanted to round to the nearest million. So your answer should end with million. If you put like a 4 here, then you'd be saying something like 25,400,000, right? That's not ending with a million. Does that make sense? Okay. This all good? Okay, so let's see. Is there not one with a 5? Why don't y'all do those? This is group work, which means you work together or work alone. Let's see if y'all can round those 4. First one to the nearest hundreds, the second one to the nearest 100 billion, nearest 10,000, and then nearest tens. I'll give you a few minutes to get this going. When you're done with all 4, raise your hand and I'll come by and check them. If you're not sure what places or what values, talk to your neighbor. Maybe they know. You got them? What did you do? I don't think you did. Did you do that one?
Oh, I did it.
I think you just wrote it down. You done? Okay. I'll come around in a second. Yeah, so this is an interesting one. That's good. Okay. Okay. Let's just go one more minute and then we'll talk about it as a group. All right, who's my new volunteer for that first one? Okay, good. Yeah. So what number am I circling? What is the number I'm interested in? The 2, right? Because the 2 is in the hundreds place. Okay, so that's the number right there. Or you know what? I think I've been underlining it. All right. So what number are you going to look at in order to round that digit to? You're going to look to the right of it. Okay. So this is one we're rounding to. We look to the right. That number is a 1, right? So if it's below 5, we do what with this? Nope. Just leave it alone. Okay? So if this number is below 5, this one that we're interested in stays the same. If this number is 5 or higher, this number goes up by 1. Okay? So in this case, it's just going to stay at 2. And then everything after that is zeros. That makes sense? Okay, so we'll have 75,200. I think we're just going to go around the classroom today. And since only a few of you have your name tags, and I don't know your names, and you ready? Yeah, I was just waiting for it. You ready? What's your name? Okay, Ariana. You know what digit? Okay, so what digit did you underline here? The one in the very beginning, right? So that's right. That is the, what, 100 billions place? Ones, tens, hundreds. 1,000, 10,000, 100,000. Million, 10 million, 100 million. Billion, 10 billion, 100 billion. Okay, so then you're looking at which number? The number to the right, right? The 7, and that number is bigger than 5, so what do? What goes up? The 1 turns into a 2, and then what comes after the 2? Zeros the rest of the way. So 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. Perfect. All right, moving along. Who's next? Which of you two wants it? You got it? Okay, this one? Oh, you want this one? Okay, this is the harder one. Oh, let's see how you did. All right, so what digit did you underline? 9. The 9? This 9, okay. And then you look to the right of it at an 8, right? And so what did this 8 tell you you needed to do with the 9?
I got 8,500.
Okay, that's correct. So you look at this number, it's 5 or higher, right? Which means this number has to go up by 1, right? But the problem is it's a 9. And so you can't round it up to a 10. You can round it up to a 10, but that means the 9 would have to turn into a 0. And then we have to carry the 1 over to that 4. So this becomes 8 And this goes up to a 10, so that's a 0, but this one goes up 5, and then we put a 0 after. So 8,500 or 8,500. Good. Okay, you ready? What digit do we underline over here? The 3, okay. And then you look at the number to the right of it. That number is less than 5, so you do what with the 3? Leave it. Okay, so I'm going to write 973, and then the 1 is a 0, comma, 0, 0, 0. There we go. 9,730,000. Done. Okay, everyone? Got this? Okay. That's it for 1.4. Moving on to 5.1. So 5.1, what we're going to do is we're going to be focusing our attention more on the decimals now instead of the whole numbers. But we still have the same chart to work off of. Okay, same chart. But now, let's look at this number. This is where things are going to be a little different. The number 0.268. Looking at that, we call that a decimal, all right? Now, the 0 that's in front of the decimal point does not have to be there. It's usually there because sometimes people write the decimals kind of real small and faint, and if you don't see it, then you might think that's the number 268. So by putting a 0 in front, that's kind of to like prevent you from accidentally thinking that's 268, in case you missed the decimal, all right? So here it is. So remember, tenths, hundredths, thousandths. So this 2 right here is how many, tells us we have how many tenths? We have 2 tenths, okay? The 6 is in the position, what position is that? This is tenths, this is hundredths. So we have 6 hundredths, hundred, the 100 THS, hundredths. And then this last one is how many thousandths we have, and we have 8 of them, right? So we write that as a fraction, 8 out of 1,000. So 2 tenths means we have 2 little slivers out of a candy bar that's been cut into 10 pieces. 6 hundredths means we have 6 little slivers of a candy bar that's been cut into 100 pieces, and then 8 out of 1,000, right? So if we look at that number together, 2 tenths plus 6 100ths plus 8 1,000ths, put it all together, and you get 0.268. I guess the main kind of moral of the story here is that decimals can be written as fractions. Fractions can be written as decimals, back and forth, all right? Did y'all hear what I just said? Decimals can be written as fractions. Fractions can be written as decimals. Is that always true, do you think? Can every fraction be turned into a decimal? Yes, it can. Can every decimal be turned into a fraction? It can't, actually. There is a way I can write a decimal right now that you cannot turn into a fraction. But that's way beyond the scope of this class, all right? Way beyond. How many of you have ever heard of the number pi? It's used with circles, right? We have a special symbol for it, right? It's the Greek lowercase p, right? It's approximately, squiggly equal signs means approximately 3.1415. Okay? So this decimal keeps on going forever, actually. And it never repeats itself. And it just keeps changing. There's no pattern to it. And this number is what we call an irrational number. It's, again, beyond what we need to know in this class. But my point is, there's no way to turn this decimal into a fraction. You cannot. It's not possible. If that were the case, then we would just write this as the fraction. We would just write it as a fraction. Now, there is a fraction that's close. If you take 22 divided by 7, someone who has their calculator out, do 22 divided by 7 and tell me what they get with on their calculator. 3.1428. Yeah? And it keeps going? Yeah, so you can already see that 22 divided by 7, it's close to pi, right? The first few numbers are the same, but after a few digits, it's not. So for a long time, historically speaking, we used 22 over 7 to approximate what pi is, but there is no way to turn pi into a fraction. Otherwise, we just tell you what it is. All right? Okay. Can I ask you another question? Let me ask you, have I told you all that story about that girl I met back in college? I don't think I've told you this story. I'll tell you a story. See, I shouldn't have recorded today. I might have to mute this. Okay, so look at this. Let's take our number line. Okay, here's 0 and here's 1. All right? Are there fractions in here? Okay, someone give me an example of a fraction that's in there.
3/4.
3/4? Okay, let's see. That would be about right here, right? Okay, someone else? Another fraction in there?
1 or a half.
A half is in there? Okay. How about like 1/4? Right? There are an infinite number of fractions in here. I could just keep going this way. I could just keep cutting this in half, like 1/8, 1/16, 1/32. I can just cut it in half. Just keep on throwing fractions in there, all right? So here's the story. Do y'all want to hear this story or not?
Yeah.
I mean, because I'm kind of wasting time. All right, I'm going to turn my microphone off. Just remind me to turn it back. Thank you for sitting through that. All right, so we have to practice, just like we did before, writing some numbers in words. But these are decimals now, right? Decimals are a little bit tricky. So, you know how when you write the word, when you write this in words, you start out, you say 300. So you're starting at the left, and you're saying like, this is the hundreds position, so you start out with 300. When you do the decimal, what's really weird about it is that you write the number, or you write just like you would say the number, right? 71. That's the way we'd say that. It's 0.71, but we write 71. Okay? That's what it would be if there were no decimal, right? 71. But what is the position of the last digit? So what is this position right here? What position is that in? It's in the hundredths position, right? The first position is the tenths. The next one is the hundredths. So we're just going to write 71 as if there was no decimal point there, and then we're just going to write after that hundredths. $71 hundredths. All right, using that same idea, what number do you see here if I were to just get rid of this decimal? 936. You said 936. It's all right. I'm not going to take off on a test if you write and. I'm just trying to get.
When I write it, it's weird. I don't do the and.
You don't do the and? Okay, yeah, that's weird. Okay, so you want me to write what? 936 thousandths. So the 0 is in the tenths, right? The 9 is in the hundredths. The 3 is in the thousandths. And the 6 is in the 10,000ths. So this is 936 10,000ths. 936 10,000ths. Weird, right? Okay, we're going to do this group work together because I promised you I'd get you out of here a little early, and I already wasted time telling you stories. Okay, so let's look at this first one. Write the number being described in each statement below. Use the place value chart in the previous page if necessary. So the average distance from the Earth to the Moon is 238,855 miles. So we want to write this number. 238,000. So who wants to, where are we at? We went through that table. We're up over here. You two decide. Who wants to tell me? Ashley, do you want to take a shot at it? We're trying to write this just in, like using the numbers. So this written as a number. So just tell me what digits to write down.
238,000.
Okay.
855.
Just like that, right? So 238,855. 238. That's the average distance from the Earth to the Moon. That many miles. Did y'all hear about that comet or meteor that almost hit? Like that was close to us the other day? You know how far it was? It was like, I think it was 1,000,000 miles. 1,000,000 miles. That's close.
Really?
Yeah. Yeah. Space is big. All right. So, yes, we good? All right. Who you got the next one then? No, you already went today. You want this one or? Okay, go for it. Can you read it? I know it's kind of small. $1,307,562.85. Okay. So 1 million. Yeah. I don't know who made this problem up. It's not really realistic. At the age of 18, Tony invested some money into a retirement fund and let it mature for 50 years. I do not think that's happening. Well, you know what?
How much did
Yeah, depends on the rate, interest rate. Okay. Go ahead.
It's going to be 1,307, 562, 085.
085, point?
No.
Because it's cents, 85
Oh,
cents.
85 cents. Yeah,
.85.
point. Yeah, I messed that up.
No? No good? Okay. 1,300,000.
I didn't read the cents part.
So let's see if this is right. Everyone? 1,000,000?
Yes.
307,000. Yes?
Yes.
$562 and 85 cents. This is right. Yep.
That makes sense.
Okay, a small paper clip has a mass of 5/10 of a gram. So where are we at? We're going around. Christian, did you already answer? You already did, right? Noah, you want to go for this one? So how would we write 5/10 using a decimal? And I'll help you out by starting out by writing 0 and then point. So which position is tenths, Noah? Is it the first position, second position, third position? Second? So that's a common mistake on decimals because they start with tenths. On the other side, decimal starts with ones, right? It goes ones, tens. But when you're... What the heck did I just do? I turned on read mode. I didn't want read mode. With decimals, right? The first position over is tenths. Okay, so you have to remember that. On the other side, you start with ones, but with decimals, there's no oneths. Okay? It starts at tenths. All right, so does that help? Okay, so what am I going to put? We want to put 5/10, so what am I going to write here? It's going to be this first position, right? How many of them do we have? How many tenths? 5, right? So we just put 5. That is 5/10. 0.5. 0.5. Sebastian? You want to get the next one? No? Nothing? You want to try it? I'll help you out. Yeah, give it a shot. Okay, so 123 10,000ths. Okay, so let's think about this. We're talking about a decimal, right? Because it says 10,000ths. Okay, how many digits out is 10,000, Sebastian? 10,000ths. So what's the first position? Tenths, hundredths, thousandths. Yep. When you get to thousands, then you go 10,000s, then 100,000s, then millions. So it was tenths, hundredths, thousands, 10,000s. And that's what we have, right? I'm going to stop right there. Okay, now we want to put in there 123. So if I need to write 123 in here, I'm going to have to put what here? 0, good. And then 1, 2, 3. Does everyone see how that works? You have 123, but tens, hundreds, thousands, 10,000ths. A little tricky. Okay, so how do we round decimals? Same principle. The same exact principle as we did for the other numbers. So let's try and round these. All right, so where are we at? You already answered? Do you want to try this first one? Or? Okay, so we want to round this number 0.69235 to the nearest hundredths place. So what digit should I underline? What is the hundredths? Uh-huh.
The 9.
The 9. Okay, so we're going to underline the 9, and then we're going to look to the right of it, and that's a 2.
So it's gonna round to 0.
This one, are we going to do anything to the 9? Since this is a 2, we are not going to touch the 9.
Yeah.
And then everything else becomes zeros.
Yeah.
Okay, I think that's what you meant.
Yeah.
6, 9, and then 0, 0, 0. Good. All right, Emma, you keeping up? You all right? I'll write it down. Okay, what digit are we underlining here? The 8. Does everyone agree? We're going to the 2, 10,000th place. So this is tenths, hundredths, thousandths, 10,000ths. So we underline that. We look to the right of it at the 8. And since it's an 8, what are we going to do with that 2, Emma? Round it to a 3, and then everything after it becomes zeros. So 40.046300. Making sense, everyone? All right, this one right here, I think I can just leave it there. Where are we at? Hi. You ready? So what digit am I underlining? I need to be at the thousandths place. So 8 is tenths, right? Hundredths? The 7. Okay, so underline the 7. That's your thousands place. Look at the number to the right of it, which is a 4. The 4 tells us that we are going to leave it or round it up? Leave it. Okay, so we're going to write 7, 8, 3, 7, and then what comes after that? So what do we do with these? Since we've already done the rounding, these digits become zeros. All right, Katie, you want this one?
What did I say?
Tenths place. So what digit are you going to underline? Which one are we rounding? Trying to round.
I'm confusing myself. It's out of the 2 and 9, right?
Okay, so tenths means you're on the right side of the decimal. The 9, okay, and then we're going to circle the one to the right of it.
Don't they just become 0?
Yep, they just become zeros. So we're going to leave the 9 alone. There we go. Okay, we good? All right, how about comparing two decimals together? Figuring out which is bigger or smaller. So comparing decimals is very similar to comparing numbers. You just we're going to start from the left and move right, and we're going to see which numbers are bigger. So looking at this one right here, they both start out 0 point, right? 0 point, and then we look at the first digit, the one in the tenths position. This is an 8, that's a 7, right? Right now, right here at this step, because 8 is bigger than 7, this side's bigger than that one. Yes? Okay, now, this one's a little tricky because they're negative. And remember with negative, it's smaller is actually the bigger one because it's to the left. So ignore the minus for now. They both have 0.4, right? So the 4s are the same, but then this one is 6 and this one is 1. So this one would normally be bigger, right? But because they're negative, you want the one that's further that way. The one that's further that way is smaller. So we should point it like that. In other words, this is negative 0.41 here, and this is negative 0.46 here. This number is to the left of that number on the number line because 0's over here and you go negative that direction. So you just have to be a little careful with the negatives. How about this next one? Which one's bigger? So they both have 12. They both have 5, 5, 5, 5, 8, 8. This has 4. This one has, what's really after that 8? It's a 0. If it's not there, it's a 0. So which one's bigger? The one on the left or the right? The one on the right's bigger. All right, what about these two? They're equal. They're both 9.1100. 9.11, if there's nothing written, it's 00. So these are equal.